My name is Austin Stevenson. The date is February 21st and the time is 10:21 p.m. As you can see, there has been some crystalline growth on the sides of the vial from when it got knocked over, but the rest of the solution has completely evaporated now, leaving the bulk of it as this chunk of a crystal down here in the bottom. And as you can see from one side, it does tend to have a more triangular shape, while from the other side, it has a sort of kind of rectangular shape. It looks like it kind of got chipped off a bit there, but I actually think it looks pretty cool if you like just move it around in the light. And what I think would help synthesize a huge singular crystal more easily would be to leave the solution in a room with a temperature just like 1 or 2, maybe even 3 degrees above the solution's evaporation point. That way the solution will evaporate as slowly as possible, leaving as much time for the crystals to find one another and group together as the solution evaporates, therefore giving the highest chance of making one huge crystal. For the significance of D-spacing, each crystalline solid has its own unique D-spacing, which gives it its own crystalline look and its own chemical fingerprint, if you will. And scientists are able to experimentally identify this D-spacing in order to discover what crystalline structure a certain crystalline form has. That was a sentence. And for the math to find the D-spacing for the highest peak on the graph, you start with the original equation of n lambda is equal to 2d sine theta, with d equal to the distance of between the planes. From the graph, you can see that the angle at the highest peak is equal to 10.33 degrees. And we were told that n is equal to lambda, or is equal to 1. Plug in these values and you get 0.15418 is equal to 2d sine of 10.33 degrees. And if you shift everything around, you'll get d is equal to 0.15418 over 2 sine of 10.33 degrees. And when you plug this into the calculator, you will get d is equal to 0.43 nanometers, which is the space between the planes at the highest peak on the graph.